Hello and welcome. My name is Kevin Ball, and I will be narrating the HydroDoc Rotary Distributor training video. WesTech Engineering is the supplier of the 6 HydroDoc rotary distributors provided for TE Maxson Wastewater Treatment Plant. WesTech Engineering is located in Salt Lake City, Utah. For the video presentation, we will go over the following items: equipment overview, process overview, safety instructions, equipment operation, operational guidelines, general maintenance, orifice and arm cleaning, draining of condensate, lubrication instructions, and procedure for ordering spare or replacement parts. The first piece of equipment I would like to discuss is what we call the center mast. The center mast is designed to support the full operating weight of the mechanism and any overturning loads. Ports in the mast allow flow from the influent pipe into the distributor center barrel. So right here you can see around the circumference of the center mast we have these ports, and these are what allow the influent water to enter in to the distributor. In this illustration, the highlighted area here shows the center mast in relationship to the center barrel and the support cage. Support cage and center barrel. These are the rotating structural components suspended from the thrust bearing. The support cage carries the weight of the center barrel, the influent wastewater, and distributor arms. This transfers any overturning loads to the stabilizing bearing, where, when assembled, the stabilizing bearing is attached to the support cage right here. The rotating center barrel hangs from the support cage. The center barrel contains the influent as it flows in from the center and distributes it to the arms. This illustrates the support cage and center barrel assembled and placed over the center mast. Since the center mast is stationary and the barrel rotates, we need to have a mechanical seal to keep the influent inside the barrel as it rotates. Between the center mast and the barrel is the mechanical seal, which is pictured right here. This is designed to withstand the full hydraulic head in the center barrel. The seal consists of 2 stacked rubber rings attached to a stationary base. Stacked rubber rings seal against the stainless steel ring bolted to the bottom of the rotating center barrel. To the left is a section view of the barrel seal and its components. This right here would be the center mast, which is stationary. This portion right here is the barrel, which rotates, and these are the components that make up the barrel seal. Somewhat difficult to see all the components, but within the O&M manual is a parts list, and these bubble numbers represent the item numbers in the parts list for further detail on the components. Over here on the right is highlighted kind of where the barrel seal sits and allows the influent to stay within the barrel and then be distributed out the arms. The next item is the thrust bearing. The thrust bearing is located at the top of the center mast, as shown to the right with the red oval. Carries the weight of the entire rotating mechanism. It's oil lubricated, so it sits within a housing, so the bearing rotates within an oil bath, and it has an estimated life of over 30 years. Distributor arms. Distributor arms are fabricated in tapered sections and bolted to the center barrel. There are two primary arms and two secondary arms. Arms convey wastewater to the discharge ports, with spreader assemblies located along the sides of the arm. At low flow, you will most likely see only water coming out of the two primary arms. As flow increases, eventually it will go over an internal weir and then flow out the secondary arms. So in observation, at times you will only see flow out of two arms, and then flow increases, it will be out of all four arms. Proper rotation of the rotary distributor is clockwise, as shown by this directional arrow here. Primary arm number 1 has 47 discharge ports. Primary arm 2 has 46 discharge ports. So in this diagram, here's our primary arms. So primary arm number 1 has 47 discharge ports along this side of the arm. 180 degrees on this side is primary arm number 2. It's a little bit different configuration. It only has 46 discharge ports along this side of the arm. Secondary arm number 1 has 47 discharge ports, and secondary arm number 2 has 46 discharge ports. So secondary arms are here. So secondary arm number 1 is located here, and then 180 degrees is secondary arm number 2. So technically, primary arm number 1 and secondary arm number 1 are the same configuration. So primary arm number 1 here, secondary arm number 1, same construction. Same would hold true for primary arm number 2 and secondary arm number 2. So primary arm 1 here, primary arm number 2 here, secondary arm number 2 here are the same configuration. As mentioned before, the only thing that we differentiate basically is primary arms is where the flow first goes through those arms, and then as flow increases, you'll get flow out the secondary arms. This drawing shows the difference between the different arms. The top arm, labeled arm number 1, would be for primary arm number 1 and secondary arm number 1. And as mentioned, the discharge ports, there are a total of 47. So starting out here at the very tip of the arm, we start with discharge port number 1 through increasing to the last discharge port near the center barrel is 47. And then for arm number 2, same thing out at the tip, number 1, but this only goes up to 46 discharge ports. So this would be associated with primary arm number 1 and secondary arm number 1, the bottom secondary arm number 2, and primary arm number 2. The reason these are numbered, and there's a table in the O&M manual, each one of these discharge ports will have a corresponding orifice size. And so we have a table that shows the orifice sizes at each one of these locations. It's also important to note that, and which we'll talk about in later slides, is out at the very tip of the arm, you'll notice that there's discharge ports on both sides of the arm. About 16 in total, starting from the tip of the arm in. So there's gate assemblies that are located in these discharge ports that vary the flow to either side of the arm for control of the distributor speed. So that holds true for both arm number 1 and arm number 2. Out here, you have discharge ports on both sides of the arm. So keep that in mind. Spreader assemblies. Spreader assemblies consist of an orifice and a polycarbonate spreader. Spreaders are bolted to discharge ports along the arms. There are a few spreaders that do not contain an orifice in certain locations. Spreaders are used for even flow distribution over the media. In Appendix A of the O&M manual are tables for the primary and secondary arm orifice sizes and locations. So in the diagram shown, this is our discharge port, and as we discussed, for the sake of discussion, the table to the right is for primary arm number 1, which has discharge ports that we talked about, numbered from 1 out at the tip through 47 near the center barrel. So location number 1 up to 47. So this diagram showed this would be the discharge port, and at the discharge port there is what we call an orifice and then a spreader. So the table in the right has for trickling filters 1 through 6 at each discharge port, it shows the corresponding orifice size. However, you will notice that over to the very far right, this is what originally WesTech came up with for the orifice sizes. However, during startup, it was determined that we needed to adjust those to get better flow distribution over the media. So that's why you'll see different numbers in these columns. However, one thing important to keep in mind is that these numbers here represents the diameter of hole in the orifice plate. But 3.5, if you ever see the number 3.5 shown, 3.5 inches, that means that there is no orifice plate. It means the inside diameter of the discharge port is 3.5 inches, so it's unrestricted. It's fully open. So no orifice plates wherever you see 3.5 inches. However, if you see other numbers, for example, we'll look at discharge port, which would have an orifice size for trickling filter 1 at 2 3/8. So that means that diameter hole for that particular orifice at that location is 2 3/8 inch diameter. Support rods and cables. Vertical tie rods are designed to carry the entire weight of the arms full of water. Horizontal cables keep the arms straight and at the correct spacing, or 90 degrees from one another. The speed sensor assembly is located at the top of the distributor. An encoder in the speed sensor sends a signal back to the PLC control panel that is converted to a speed in RPM. The speed is shown on the HMI screen on the PLC control panel. Positioner assembly. A stainless steel enclosure containing a pneumatically actuated cylinder with a linear positioner. Actuated cylinders are supplied with pressurized air from a compressor located in a building near the trickling filter. The linear positioner is supplied with signal air from the air control panel with a pressure range of 3 to 15 psi. One positioner assembly is located near the end of each arm. Attached to the positioner rod are linkages that move the gate assemblies. Gate assembly. This picture below shows the gate position as the air cylinder rod moves in and out. Not all discharge ports have gates. It is only the outermost 16 that have the gates on the discharge ports. So for the picture on the left, it shows the air cylinder rod fully retracted, which would be if it's receiving a signal from the air control panel at 3 psi, that would be the position of the rod. So the linkages will affect the gate position. So in this example here, with the rod fully retracted in at 3 psi, the gates on this side are fully open, and the gates on this side, which you can't see, but they look like these, are fully closed. Just the opposite is true. If the air rod cylinder is fully extended all the way out, that causes these gates to be closed and these to be fully open. Anywhere in between 3 to 15 psi causes these to be a certain percentage, open or closed. But just be aware that the gates, the linkages cause these gates to open and close opposite of each other. So as these are opening, these are closing, vice versa. As these are closing, these would be opening. So in this scenario, it would allow counter thrust out the side of the arm to slow it down. In this example, they would be closed, so you're getting thrust fully from this side of the arm to speed the distributor up. The control system. The control system consists of a PLC control panel and an air control panel. These panels work together to control the rotational speed of the distributor. On the left is the PLC control panel. On the right is the air control panel. Process overview for trickling filters. Trickling filters are used to remove organic matter from wastewater. This type of treatment process utilizes microorganisms attached to a medium to remove organic matter from wastewater, known as attached growth processes. This enables organic material in the wastewater to be absorbed by a population of microorganisms that are attached to the medium as a biological film or slime layer. As the wastewater passes over this slime, the slime absorbs the organic matter. The organic matter is used for food by the microbes. At the same time, air moving through the open spaces in the filter transfers oxygen to the wastewater. Oxygen is then transferred to the slime to keep the outer layer aerobic. As the microbes use the food and oxygen, they produce more organisms and other stable byproducts. Safety instructions. The HydroDoc rotary distributor is designed to continuously distribute wastewater over trickling filter media. Never stand or place any object in the path of the rotating arms. Never walk on the arms while they are moving. Mechanism and accessories must be stopped before performing any maintenance or adjustments. Ensure that all guards, handrails, and other safety devices are in place and functioning before operating this equipment. Lock out electrical power and wastewater flow before beginning any inspection or maintenance procedures. Tie off one or more arms during maintenance to prevent unexpected distributor movement due to wind gusts, residual flow from the arms, etc. Exercise caution around moving parts. Keep hands and clothing away from moving parts. Do not wear loose clothing, loose hair, or jewelry when working on or around the equipment. Ladders, platforms, railings, and other working surfaces may become icy or slippery. Exercise caution at all times to avoid slipping or falling. Never attempt to stop the unit by pushing or pulling on the arms. Always allow the distributor to coast to a stop. Exercise appropriate cautions when working around wastewater. Wash thoroughly after coming in contact with sewage. The HydroDoc mechanism provides the means of controlling the rotational speed of a rotary distributor using the hydraulic energy available from the influent stream. The HydroDoc provides the means to direct the flow through ports in the front and back of each arm varying the proportions resulting in thrust or speed control. Discharge ports with spreaders are appropriately placed along the front wall and back wall of the outer arm sections. A gate is placed in front of the discharge ports at the outermost section of each arm. These gates are located inside the arm. The front and rear gates are raised and lowered in opposite directions to each other. For example, as one closes, the other opens. The gate linkage is attached to the gates and moved by an air cylinder fitted with a pneumatic positioner. The positioner causes the cylinder to extend or retract as required. Each positioner is configured such that when the rod is extended, the distributor speed increases. Conversely, as the rod is retracted, the distributor speed decreases. The HydroDoc control system consists of a PLC providing comparative monitoring of the actual rotating speed of the arms and a set point representing the desired rotational speed. Based on the results of the comparison, a signal is generated and sent to the air control panel. In the air control panel, the signal is converted by an I to P transducer from a 4 to 20 milliamp electrical signal to the 3 to 15 psi pneumatic signal, which is sent to the positioners out on the rotary distributor arms. Feedback to the PLC is generated by an encoder mounted within the speed sensor assembled at the top of the distributor. This sensor returns a signal that gives both rotational speed and the direction of rotation. This discrimination allows the control logic to make very responsive speed changes and gives the ability to maintain a zero, for example, stop or maintenance speed. The HydroDoc control system offers 3 modes of operation. These modes are offered by the selector switch on the front of the PLC control panel, which are hand, remote, and auto. Hand mode, the positioners and gates simply move to the position selected by the control panel potentiometer. The PLC is bypassed. Auto mode, the distributor is controlled by the PLC in accordance with the program set points. The PLC will adjust the distributor gates to compensate for changes in flow, wind forces, clog nozzles, etc. Remote mode, the speed set point is taken from a 4 to 20 milliamp signal supplied by a remote source. As in auto mode, the PLC will attempt to hold the desired speed by compensating for flow, changes, wind forces, and other external effects. It's also important to note there is a 0 speed button that can be used to stop rotation of the distributor without stopping flow of the wastewater. Automatic mode PLC settings. The WesTech PLC control panel contains a PLC and an HMI touchscreen. The touchscreen is shown in the figure to the right. The main overview screen displays distributor rotational speed in both revolutions per minute and minutes per revolution. It also indicates the current control mode, whether it is in hand, remote, or auto. It also shows the current date and time. The main screen also contains time setup and alarm buttons. When pressed, will access other setup and information screens. Automatic program setup. From the main overview display screen, press the time setup button. The automatic program setup screen will be displayed as shown in the figure to the right. The automatic program setup screen allows up to 8 different set points with a start time, stop time, and speed. Each program speed set point will operate between the start set point and end set point, each associated with a specific time period within a 24-hour day. Times are based on military time. A default speed must be set. This is the speed at which the distributor will operate when not controlled by any of the 8 speed set points. First, determine an appropriate default speed and set it by pressing the screen on the current default value. Automatic program setup continued. Set points are active when green and inactive when red. Set points can be toggled by simply pushing the button on the HMI screen. A complex program could be set with multiple set points that together span the full 24 hours for each day. Or a simple program could have a single set point for a daily flushing period. So for example, a really simple program setup would be to have set point 1 active, set point 2 through 8 inactive. So let's say you wanted to run it from 3 to 4 a.m. at a really slow speed for a flushing cycle. You could set your start hour at 3 and your start minute at 0, your stop hour at 4, your stop minute at 0, and change your distributor speed to 40 minutes per revolution. So from 3 to 4 in the morning, it would run at 40 minutes per revolution. All other times of the day, it would default to whatever is set here. So in this case, it would default to 8 minutes per revolution. Or you could have a very complex setup where you use all set points and you can vary throughout the 24-hour period, multiple start times, stop times, and multiple distributor speeds. In this case, there's 3 set points that are active. So set point 1 runs the distributor from 3:30 to 4:30 at 20 minutes per revolution. Set point 2 runs the distributor from 4:30 to 8 p.m. at 15 minutes per revolution. And set point 3 runs the distributor from 8 to 9 p.m. at 7 minutes per revolution. However, it's important to note if you have adjacent times, they can't be the same. So in this case, between set point 1 and set point 2, your start and stop have to differentiate by at least 1 minute. So here, your stop is at 4:29 and your start is at 4:30. And then, for example, on this one, your stop is at 7:59 and your start is at 8 p.m. Just keep in mind that we're dealing with military time. It's also important to note that you cannot have set point times that span over midnight, so it won't work correctly. So if you've got to span over midnight, you'll have to do 2 set points. So for example, if you had to run it from 10 p.m. to 3 a.m., you'd have to do two set points. One set point would be from 10 p.m. to midnight, and the other set point would be from midnight to 3 a.m. So the first set point from 10 to midnight, you would have to do your stop hour at 23 and your stop minute at 59. And then from starting at midnight to 3, you would have your start hour at 0 and your start minute at 0 as well. So you just can't have it's split over midnight. Hand mode operation. In hand mode, distributor speed is controlled by a potentiometer located on the front of the PLC control panel door. Move the selector switch to the hand position. Rotate the potentiometer dial to control the distributor rotational speed. The air panel I to P transducer converts the 4 to 20 milliamp signal received from the potentiometer into a needed PSI for the gate positioners. 3 PSI results in fully open gates on the front side of the arm to reduce speed. 15 PSI results in fully open gates on the back side of the arms to increase speed. Note, if there is a condition that exists where power is lost to the air control panel, but compressed air is still available, there is a pressure regulator that can be adjusted to control the speed of the distributor. So, in normal operation, there is a solenoid valve located up here, which is normally open. So air will flow from the air dryer, come in through this tubing into the I to P transducer, which converts it to the signal air pressure, and it comes out of the I to P transducer in this tubing right here and goes up through this solenoid valve out to the rotary distributor. If there is a loss of power, this solenoid valve will close, and now the air will come through this tubing through this pressure regulator and up and out to the rotary distributor. But the air pressure can be varied using this air pressure regulator right here. So you can adjust the pressure to control the speed if you still have compressed air, but the air control panel is off. Operational guidelines. Optimum operational speed of a rotary distributor is a function of wastewater flow and loading. Initially, the rotary distributor should be configured to rotate at approximately 4 to 6 minutes per revolution. Typical plants require 3 to 6 weeks for full biological growth when media is new or hasn't been recently used. After sufficient biological growth, the rotary distributor speed may be adjusted to optimize trickling filter performance. Operating speed may be calculated based on typical wastewater flow, loading, and seasonal temperatures, etc. Periodic flushing of the media is an important part of maximizing trickling filter performance. Flushing is typically done by slowing the distributor to 40 minutes per revolution on a daily basis at times of lower flow and loading. Too little flushing will allow excessive amounts of biological growth to build up upon the media. Too much flushing will diminish trickling filter performance since flow passes through the media at a rate faster than it can be treated. Proper flushing speed, frequency, and duration must be determined by the operators based on testing and process results. General maintenance. WesTech rotary distributors are designed to have minimal maintenance requirements. Proper orifice cleaning and arm flushing is a necessary periodic maintenance item. Bearing lubrication. Lubricate according to instructions. HydroDoc, gates, linkage, and positioner component inspection. Check all parts for loose fasteners, signs of overload damage. Seals and gasket checks. The barrel seal and all arm gaskets should be inspected at least annually for cracking, leaking, or other deterioration. These must be replaced as necessary. Anchors and fasteners check. All anchors and fasteners should be annually verified as tight. Any corroding fasteners should be replaced. Tie rod and support cable check. Annually, all tie rods and support cables should be checked for proper tensioning and load sharing. Arms should be rechecked for level if any tie rod adjustments are required. Draining of condensate from air lines. Orifice and arm cleaning. Shut off flow to the distributor, lock out power to the controls, allow the arms to stop. Open flush gate on each arm and allow the arm to fully drain. Inspect each orifice. Use a brush to clean any obstructing material from the orifices. If possible, draw the material out through the orifices and collect for disposal. Otherwise, push it back into the arm. Clean the vent pipes on the top of each arm. Start flow to the distributor and allow the arms to flush for several minutes with the flush gates open. Close the flush gates and observe each arm for uniform water distribution. If any orifices still appear clogged, repeat the procedure. When all spreaders are giving proper water distribution, check that all flush gates are securely closed and return the distributor to normal surface. Drip leg draining. Drainage of condensate. Regularly open the condensate drain valves on the drip legs near each positioner assembly. Allow collected condensate to blow out. The frequency of this check must be determined based on plant conditions and the quality of the air supply. Lubrication summary. Below is a table that lists the required lubrication for the rotary distributor. First is the thrust bearing located near the top of the center mast. We recommend a mobile SHC 634 oil. It should be checked every month for any condensate that's allowed to collect in the oil, and we recommend that the oil be changed every 6 months. It's approximately 3 quarts of oil that's required for the thrust bearing. Second is the stabilizing bearing. We recommend a Mobilith SHC PM 460 grease. It's to be greased monthly, approximately 10 to 12 shots of grease for lubrication. Last is the positioners. We suggest monthly on the positioner rod that it receives a light coating of waterproof silicone grease so that the rod moves in and out of the positioner assembly without friction. Upper bearing. Check for proper oil level and for the presence of condensate every 30 days. Drain condensate using the oil drain valve. Top off oil level as required. Change every 6 months. Recommended oil is Mobil SHC 634. Approximate volume is 96 fluid ounces or 3 quarts. The proper oil level can be determined by removing the oil level port plug. Oil should be at the bottom. Oil level should reach the bottom of the oil level port plug. Upper bearing. To change the oil, open the drain valve and catch the oil in a small can or bucket. Remove the fill cap to increase the drainage rate. After draining, close the drain valve. Remove the oil level port plug. Remove the 2-inch cap and add new oil into the fill port until oil reaches oil level plug. Replace the level plug and fill cap. Ensure that the threads are sealed with pipe dope or tape to prevent moisture from entering the bearing housing. Lower bearing lubrication. Add 10 to 12 shots of grease every month. For best results, rotate the arms 90 degrees between every 2 to 3 shots. Recommended grease is Mobilith SHC PM 460. Check sealant on the bearing cover is intact to prevent moisture entry into the bearing housing. Positioner extension rods. Wipe a small amount of waterproof silicone grease on each positioner extension rod near the enclosure seals. It is recommended to do this on a monthly basis. Procedure for ordering spare or replacement parts. Spare or replacement parts may be ordered from the aftermarket sales department by email at parts@westechwater.com or by phone 801-265-1000. Should you require further assistance in determining which spare parts are appropriate for your particular situation, please contact WesTech's aftermarket sales department. Identify equipment using the WesTech job number. Your equipment is identified as follows: WesTech job number 24416A, WesTech model number RDS 13S, equipment type 6 HydroDoc rotary distributors. Please refer to WesTech's O&M manual for more in-depth information. Thank you. This concludes the video presentation.